So we've looked at two forms already. We've looked at vertex form, which gives you the vertex and the transformations. We've looked at intercept form, that gives you the X-intercepts specifically. And now we're going to look at standard form. So quadratics in standard form. And you guys have already seen this, because this is just y equals ax squared plus bx plus c. So we've already been working with standard form a little bit. We've been factoring from that form. Yep. We've been factoring from this form. We've also done the quadratic formula from this form. So we've worked with it before. We just haven't done things like finding the vertex from it and stuff like that. So when you look at this form, the letter A in front still means what it's meant every other time. So what can we find using A? Yeah, we can see if it's stretched or compressed. And there's one more thing. Yeah. So reflect over X. The nice thing about that is that we can still see, before even working with the problem, we can still see if the parabola goes up or down, which is helpful for when we get to things like domain and range and increasing and decreasing. We don't want to do all the work. We just want to have a little sketch to look at. The other thing that we can find from standard form really easily is the y-intercept. Does anyone have an idea what the y-intercept might be? Yeah, it's the c value. It's the number on the end. And that's because if you plug 0 in for x, if you plug 0 in for x here, then a times 0 is just nothing. And then if you plug 0 in for x here, b times 0 would be nothing. And so these two would be canceled out, and you would just end up with the c on the end. So y-intercept is going to be pretty easy to find. All right, so if we look at a picture, here's a parabola. We're going to say that y-intercept right there is c. And we've got the axis of symmetry that goes down the middle. Are you taking notes while you blow bubbles? Okay. And the axis of symmetry is always written as x equals a number. And the way that you figure out the number that x equals is you do negative b divided by 2a. Negative b divided by 2a. So it's the opposite sign of the number that's in front of x, and then divided by 2 times the number in front of x squared. So that's the axis of symmetry. The vertex is going to have that same number as your x coordinate. So that number gives you the x value of your vertex. And then any ideas how we would find the y coordinate of the vertex? Yeah, plug that number in for x. So plug number in for x to get y. So there's your vertex. So you do negative b over 2a first, get the answer, and then plug it back into the equation, and then I'll tell you your y value. So what you'll notice is I haven't made any reference to the x-intercepts, and that's because in this form they're not easy to see unless it's something that can be factored easily. So in this form, typically I'm just going to say don't worry about graphing your x-intercepts, only find them if I ask for them, and you can find them on a calculator. Right? So for this, when we graph them, we're typically not going to look at our x-intercepts. Okay, so for our first example, we're going to sketch the graph for y equals negative x squared plus 4x plus 3. and we're going to find the basically the three things we just found. So we're going to look for the y-intercept, we're going to look for the vertex, we're going to look for the axis of symmetry, and once we find those things, we're going to start drawing a sketch, and then we'll come up with more stuff from there. So what's the y-intercept? 3. Yep. So if you plugged in 0, you get 3. What do I have to do to find the x-coordinate of the vertex? So it would be negative
4.
So negative 4 over 2 times negative 1. So that's negative 4 divided by negative 2. So negative 4 divided by negative 2 is positive 2. So our vertex has an x-coordinate of positive 2. And then how do we find the y-coordinate? Yeah. So we're going to say negative of 2 squared plus 4 times 2 plus 3. And you can go ahead and type it in exactly the way it looks. So calculators, I should hear some clicking because you're typing it in for me. This is the y-coordinate of the vertex. Double check when you're typing it. Does it look just like this on your calculator screen? So it should look just like this. Yeah, it should give you 7. So 7 is the y-coordinate. And then what's your axis of symmetry? X equals 2. Okay, so we're going to go ahead and sketch this graph. So we've got a point at 0, 3, and we have an axis of symmetry at 2, and we have a point at 2, 7. Are those 2 points enough to draw a parabola from? Nope. So we can do the opposite of what? Yeah, we can take this and just kind of think of it reflected over. So it was 2 away from the dotted line, so I can do 2 away from the dotted line on the other side. And the other day I said that when we do our graphs, I want you guys to have at least 5 points, and we only have 3 right now. So that means we have to find 1 more, and then we can reflect it. So you guys have options for what numbers you want to plug in for x. We could plug in negative 57 for x. Do you guys want to do that? No, that would be terrible, right? That'd be hard to graph because it'd be so far off our graph. What's an x value that you can see that's like pretty close to the other x values we already have? So 2 is one we already have. It's 2, 7, right? So what else could we plug in? You could plug in 1. 1's a good one to plug in because we know the point would be somewhere in between these two. We know it's not too big. You could plug in negative 1 as well. There's just a chance it's most likely going to be off of what we graphed already. So I would say plug in 1. I'm going to write on my notes other points because you are going to have to do this when you graph these. You're going to have to find at least 1 other point to plug in. And so I'm just picking the one that's easy to plug in that looks kind of close to the other points I've done so far. So I know the x-coordinate of my point is 1. How do I find the y-coordinate of my point? Yeah, plug it in. So for my y-coordinate, I'm going to have negative of 1 squared plus 4 times 1 plus 3. Yeah, positive 6. So I've got the point 1, 6. And what's another point that I have? Yeah, the opposite of that. So if I reflect that over the axis of symmetry, that would give me the point 36 as well. And at this point, I've got all 5 points for my parabola. Look, something like that. So, example number 2. We are going to find all of the characteristics. For y equals 2x squared minus 8x plus 3. So when we look for all of the characteristics, we're looking for the vertex, the axis of symmetry, we're looking for the x-intercepts, the y-intercept, the domain, the range, the increasing, the decreasing, the max, and the min.
That's a lot of things.
It is a lot of things, yeah. So, the vertex should be pretty good by now. How do we find the x-coordinate of the vertex? Negative b over 2a, which for this problem would be
8 over 4.
Yeah, 8 over 2 times 2, which is 8 over 4. And that's 2. And that also told us our axis of symmetry, right? Since that's the same as the x-coordinate of the vertex. How do we find the y-coordinate of the vertex? So 2 times 2 squared minus 8 times 2 plus 3. And so for your y-coordinate, you should get negative 5. We're going to ignore x-intercepts for now because those are calculator problems. How about the y-intercept? 3. How about the domain? All reals. You can plug in anything you want, or we'll say negative infinity to positive infinity. If I draw a little sketch of this parabola, does it go up or down? It goes up, so I'm gonna goes up. So if we're looking at the y values for the range, what is the very lowest y value that we can see? Yeah, negative 5 from the vertex. So what should our range be? Y is greater than or equal to negative 5, or if you like the infinities,
Negative 5.
yeah, negative 5 with a bracket around it to positive infinity. If we start to label our picture for increasing and decreasing, what do we need to label? So infinity and negative infinity. And what about this part right here? We got our stick figure. He's decreasing, increasing over here. And then what number do we put in the middle? 2, so we're using the x values. So what is our increasing interval? 2 to infinity. And what's our decreasing interval? Negative infinity to 2. Do we have a max or a min? A min. So for max, I'm going to put none. For min, I'm going to put negative 5. Okay? And then at this point, we're ready to find our x-intercepts. How do we do that? Yeah, we gotta type it in. Here, we're gonna graph it. So I've got 2x squared minus 8x plus 3. And how do I find them on my calculator? Second trace number 2. And our first x-intercept is right in here. So where the cursor landed is actually a good spot for a left bound. So I'm going to go ahead and press enter. And now it wants right bound, so I'll go ahead and move to the other side. All right, if I want to write 3 decimal places, what should they be?
0.419.
Yeah, 0.419. And then if I look for the other one, second trace again, option number 2 again. There's my left bound. And my right bound. If I did 3 decimal places for this one, what would the 3 decimal places be?
3.581.
All right, so what did we get for the x-intercept?
581.
3.581. Okay, I want to, hey guys, you should not be packing up yet. We got some time. I want you guys to look right now. What do you guys see for the y-coordinate right there?
1e.
Yeah, this is weird. I want you to listen because I'm going to be annoyed if you ask me about this and I already explained it. It says -1e, -12. This is your calculator writing an answer in scientific notation. Does anyone know what the y-coordinate was supposed to be for an x-intercept? It was supposed to be 0. So we're going to look and see why this actually equals 0. This is scientific notation. It's -1 times 10 to the -12th power. Do you guys remember how negative exponents work in scientific notation?
Yes.
It tells you, it's decimals, right? And it tells you to go left or right with your decimal place.
Right.
Left. It tells you to go left. So right now, this is -1 point. That's where the decimal place is right now. And it's telling us we need to go 12 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's our decimal place. And we put zeros all throughout here. So do you guys see how your calculator was basically saying 0? It's, you do not have to put that. It's your calculator having a technical error, basically. It's trying to say 0, it's struggling.
It's trying to be smart.
Okay, so whenever you're looking for x or y intercepts and you see that e, and it has shown up, I've watched it show up already. Anytime you see that e, it's really trying to say 0. And if you look at that point, the y coordinate of that point is definitely 0. It's definitely not -1. Right? It's on the line. Okay, does that make sense?
Is there any way to fix that, or
It just does that. Yeah. All right.